Today we will discuss that types of solid. That is chapter number 1, topic number 1 of that class 12 chemistry. First we have to discuss what is crystalline solid. Now it is a substance whose constituent particle possess a regular orderly arrangement. That means particles are arranged in a particular pattern. For example, see sodium chloride, sucrose, diamond, all these are crystalline substances. Next, you have to learn that what is polymorphic form or polymorph. Now, some substance adopt different arrangement of particles in solid state and giving rise to different crystalline structure. That means as they differ in the arrangement of particle, they give different crystalline structure. So these different crystalline form are called polymorphs. For example, monoclinic sulfur, rhombic sulfur, these are polymorphs to each other. Next, amorphous solid. Now, in this case, constituent particles do not possess regularly orderly arrangement and they have that powder-like appearance. For example, see plastic, rubber, glass.
Say. Next, that supercool liquid or pseudo-solid. Now, amorphous solid have a tendency to flow like liquid, but that rate of flow is very slow. So that's why it is called supercool liquid or pseudo-solid. Now, in our everyday life, see, now in that ancient building, that glass pane of that windows, they are thicker in that lower part compared to that upper part. So that is example of that flow of that supercooled liquid. Next one, anisotropy. Now physical properties such as that electrical resistance, refractive index shows different value when measured along different direction of the same crystal. That is called anisotropy. Now what is the reason behind anisotropy? Now different direction have different number of particles. That's why they have different physical property. Now crystalline solid are anisotropic in nature. Now isotropy, in all direction they have same physical property, and amorphous solid are isotropic in nature. Next we have to learn the difference between crystalline solid and amorphous solid. Now crystalline solid say regular arrangement of particle, amorphous solid irregular arrangement of particle. Crystalline solid have sharp melting point. Now sharp melting point means at a particular temperature whole substance that get melted. But in amorphous they have a range of melting point. That means if melting start at 105, it that continue up to 110 degrees Celsius. So it has a range of melting point instead of sharp melting point. Now crystalline solid they are called true solid, and amorphous solid they are called that supercooled liquid or pseudo-solid. Crystalline solid anisotropic in nature, and amorphous solid isotropic in nature. Next, that classification of solid based on that interparticle bonding force. First one, molecular solid. In this case, the constituent particle are molecule. Now, based on the nature of molecule, there are three different types. First one, see non-polar molecule. Now, in case of non-polar molecule, the force of attraction between the molecules are weak van der Waals force. Now, for example, see dry ice, iodine. Next one, polar molecule. Now, in case of polar molecule, the attractive force is dipole-dipole interaction. For example, that solid sulfur dioxide, solid hydrogen chloride. And third type, now in some case, the attractive force is strong hydrogen bond. Because hydrogen bond not possible for all case. When that hydrogen only attach with that highly electronegative element like fluorine, that oxygen and nitrogen, then only they able to form that hydrogen bond. So ice and that solid hydrogen fluoride. In this case, the force of attraction is hydrogen bond. Next type, that ionic solid. Now in case of ionic solid, that constituent particle are oppositely charged ion. See that all these salt, different salt, sodium chloride, zinc sulfide, These are the example of ionic solid. And in that case, the interparticle force is ionic bond. Next one, that covalent or network solid. Now don't get confused between that covalent solid and molecular solid. In case of covalent solid, see, same or different that atoms link to form a that network. In this case, same or different atom connected by each other by covalent bond and form a network. For example, see diamond, silicon carbide, silica. These are covalent or network solid. Last type, that metallic solid. Now in this case, the constituent particle are metal atoms and the force of attraction is metallic bond. Now metallic bond we can explain by that electron C model. Metal ion are in fixed position and that free electron that move. For example, see metallic solid. Now are that different type of metal, that iron, zinc. So this is the different type of that solid.